Hello everybody, it's Miss Garcia. Welcome to Math City with Miss G. In this video, we will talk about two-column proofs of parallel lines cut by a transversal. What is a transversal? It is a line that passes through two lines in the same plane at two distinct points. Let us focus our attention on the given. We're given with that A and B are parallel lines. We're also given that C and D are parallel lines. So since each of these lines passes through two lines, then each of these lines are also considered transversal line. Now, let's focus our attention to what we needed to prove. We're to prove that angle 7 plus angle 12 is equal to 180. Now we need to make a plan. How do we make a plan? So we need to introduce and make connections from angle 7 to angle 4. Why? Because angle 4 and angle 12 has a relationship, and that's what we are going to talk about in this proof. So we're going to start with number 1. A is parallel to B, and that is given. Number 2, C is parallel to D, and that is also given. For statement number 3, we then can show or introduce angle 7. So angle 7 plus angle 4 is equal to 180. So these two angles are, if you have noticed, they are on the same side of V's line, of line A. So then we can say that, or the reason would be same side, interior angles. Statement number 4 is to introduce that angle 4 is equal to angle 12. And if we focus our attention to angle 4 and 12, angle 4 and 12, they are actually considered corresponding angles. So number 4 is going to be corresponding, or definition of corresponding angles. Since we have introduced that angle 4 is equal to angle 12, then number 5 would be angle 7. Instead of writing angle 4, we are going to write angle 12 is equal, angle 7 plus angle 12 is equal to 180, which is what we are supposed to prove. And the reason for this is going to be substitution property. All right, let us try another problem. So in this problem, we are given a parallel line, J and K. We are to prove that angle 1 and angle 7 are supplementary. So in this problem, there's multiple ways to prove this, but I would like to go in this route where I will introduce 5 and then from 5 to 7. So then I can make a connection. All right, let us begin, and that's what we are going to talk about. So first, we are going to write J is parallel to K, and that is given. Number 2, since we already know that we are going to head down to from 1 to 7, we're going to introduce angle 5. Angle 5 is congruent to angle 7. And notice that these two angles, 5 and 7, they are considered corresponding angles. So our reason for that is going to be definition of corresponding angles. Or we can just say corresponding angles. Number 3, we are going to take the congruent sign, and that would be measure of angle 5 is equal to measure of angle 7. Now, this process is actually explained in what congruence is. So that means when two angles are congruent, they are considered to be equal in measure, and this is definition of congruence. Number 4 statement, we now can introduce angle 1 and angle 5. So if we focus our attention to angle 1 and 5, they actually create a linear pair. So then therefore, number 4 statement, we can say angle 1 and angle 5 are supplementary. So our reason for this is definition of linear pair. Number 5 statement would be measure of angle 1 plus measure of angle 5 is equal to 180. And the reason for that is going to be definition of supplementary angles. Now that we have introduced that angle 1 plus measure of angle 5 is equal to 180, if you notice that we already have introduced this up on top, that 5 and 7 are equal. So instead of writing measure of angle 5, we then can write in statement number 6 that measure of angle 1 plus measure of angle 7 is equal to 180. So this is substitution property. Since we have established that, then therefore we can conclude that angle 1 and angle 7 are supplementary. And reason for number 7 statement is definition of supplementary angles. Okay, I hope you find value in this video. Thank you for watching. I'll see you in my next one. Bye.